Chapter 5. Smart Contracts. Evolution and Wealth Generation. Introduction to Smart Contracts. Smart contracts, in essence, are digital agreements that automate transactions based on predetermined conditions. They function through computer programs, enabling parties to engage in contractual consensus without the need for intermediaries. These contracts are executed autonomously, adhering strictly to the rules encoded within them. Unlike traditional contracts, smart contracts operate on blockchain technology, ensuring transparency, immutability, and security throughout the process. A fundamental aspect of smart contracts is their self-executing nature, which eliminates the need for manual intervention once the conditions are met. This automation streamlines processes, reducing the potential for errors and delays inherent in traditional contract execution. Through the utilization of if, when, then expressions encoded in the blockchain, smart contracts facilitate seamless and efficient transactions. Moreover, the decentralized nature of blockchain ensures that smart contracts can operate without reliance on a central authority or external enforcement mechanism. One key distinction of smart contracts is their reliance on code rather than legal language or agreements. This code contains specific instructions that dictate the actions to be taken upon fulfillment of predetermined conditions. Additionally, parties involved in smart contracts must provide their approval through digital signatures to proceed with the specified terms and conditions. This ensures the integrity and authenticity of the agreement within the digital environment. A digital vending machine. A smart contract can be likened to a digital vending machine, embodying predefined logic similar to how a vending machine dispenses snacks based on specific inputs. Just like inserting money and selecting a snack results in the vending machine dispensing the chosen item, a smart contract executes predetermined actions when certain conditions are met. This logic, akin to the vending machine's programming, governs the behavior of the smart contract. For instance, in a simple Solidity smart contract representing a vending machine, the code might declare state variables such as the owner's address and maintain a mapping of users' balances for purchasing potato chips. Solidity, Smart Contract Code. Pragma Solidity 0. 8. 7. Contract Vending Machine. Declare state variables of the contract. Address public owner. Mapping, address equals greater than UINT, public potato chips balances. Additional contract logic and functions can be added here. Closing curly bracket. Smart contracts find applications across various industries, from finance to real estate, due to their versatility and efficiency. In the cryptocurrency industry, smart contracts are widely utilized for trading coins, facilitating secure and transparent transactions. Beyond finance, sectors such as insurance and real estate are adopting smart contracts to streamline processes and enhance scalability. This widespread adoption underscores the potential of smart contracts to revolutionize traditional contractual practices. One notable advantage of smart contracts is their ability to automate complex processes, such as asset transfers or registration procedures, with minimal human intervention. Once the predefined criteria are met and confirmed, a network of computers executes the necessary actions seamlessly. This not only reduces the administrative burden but also enhances the speed and accuracy of transaction processing. Consequently, smart contracts offer significant efficiency gains compared to traditional contract mechanisms. Origins of smart contracts. A historical perspective. The founding of smart contracts traces back to 1994 when Nick Szabo, a renowned American cryptographer, introduced the concept and further elaborated on it through various writings. Alongside Szabo, Ian Grigg and Gary Howland also contributed to the development of smart contract ideas. However, it wasn't until the emergence of platforms like Ethereum that the concept gained significant traction. Ethereum, with its blockchain technology, provided the infrastructure necessary for the implementation of smart contracts. Building upon the groundwork laid by Bitcoin, Nick Szabo envisioned smart contracts as a means to digitize transaction techniques, including point-of-sale, POS, and to execute contracts for synthetic assets such as derivatives and bonds. by integrating securities like bonds with derivatives such as options and futures. Complex payment structures could be automated and traded with minimal transaction costs. This vision revolutionized contract management by introducing automation and standardization to the process. In practical terms, smart contracts operate as self-executing protocols that automatically enforce the terms of a contract once predefined conditions are met. Szabo's vision emphasized the potential for these contracts to simplify transactions and reduce the need for middlemen. Today, platforms like Ethereum facilitate the deployment and execution of smart contracts, enabling a wide range of applications across industries. Despite the speculation surrounding his identity, Szabo's contributions to the field of cryptocurrency and smart contracts remain significant. His ideas laid the foundation for the development of blockchain-based technologies and paved the way for the emergence of decentralized finance, DeFi, applications. As the adoption of smart contracts continues to grow, Szabo's vision of automated, trustless transactions is becoming increasingly realized in the digital economy. Exploring the applications of smart contracts. Smart contracts serve a multitude of purposes, offering a modernized approach to executing agreements between parties. At its core, smart contracts ensure the smooth completion of transactions, such as the exchange of goods or services. Take, for instance, a scenario where a manufacturer needs raw materials. Through smart contracts, payments can be set up, and shipments coordinated with suppliers seamlessly. The automated nature of smart contracts allows for funds to be transferred upon fulfillment of predefined conditions, eliminating the need for manual intervention. Various industries benefit from the versatility of smart contracts, including real estate, stock trading, lending, and supply chain management, to name a few. Their adoption across these sectors is driven by the autonomy, security, and cost-effectiveness they offer. However, despite their advantages, instances of security breaches resulting from coding errors highlight potential risks associated with smart contracts. Additionally, the immutable nature of smart contracts poses challenges in rectifying mistakes or modifying contract terms once deployed. While smart contracts continue to gain traction, their widespread adoption is not without hurdles. Legal considerations play a crucial role in their acceptance, with many jurisdictions working to address regulatory concerns surrounding their use. States like Arizona and Nevada have taken proactive steps by amending their Electronic Transactions Acts to explicitly recognize blockchains and smart contracts. These legislative efforts signify a growing acknowledgement of the importance of blockchain technology and its role in shaping future contractual practices. Assessing the pros and cons of smart contracts. Smart contracts offer several advantages, primarily stemming from their ability to eliminate the need for intermediaries. This efficiency translates into faster contract execution, reducing delays often associated with traditional methods. Additionally, the automation inherent in smart contracts minimizes the risk of human error, ensuring accuracy in contract implementation. Furthermore, the immutable nature of smart contracts, once deployed on a blockchain, provides a level of security and trust, as the programming cannot be altered. However, smart contracts also come with limitations and drawbacks. One significant limitation is their permanence. Once deployed, smart contracts cannot be changed, making them unforgiving of mistakes or unforeseen circumstances. Moreover, the reliance on programmers to ensure the code accurately reflects the terms of the contract introduces a human factor that can be prone to errors. Additionally, there is the risk of loopholes in the coding, which could potentially be exploited for executing contracts in bad faith, highlighting the importance of thorough testing and auditing. While smart contracts offer efficiency and security, there are certain tasks they cannot currently perform. For instance, they are confined to operating within blockchain networks and cannot access external information from sources outside the blockchain, such as websites. To address this limitation, developers have introduced off-chain data feeds called oracles, which act as a bridge between blockchain networks and the real world. However, Concerns regarding data validity and decentralization arise with single-source oracles, and the security of oracles can be compromised if linked to insecure websites. Moreover, the legal recognition of smart contracts varies across jurisdictions. While they can be legally enforceable if they adhere to traditional legal contract principles, their legal status depends on each country's regulations. Developers often design smart contracts to function independently of the legal system, eliminating the need for third parties like lawyers. However, this approach raises questions about legal enforceability and the resolution of disputes, underscoring the complexities surrounding the integration of smart contracts into existing legal frameworks. The role of smart contracts in Ethereum's decentralized ecosystem. Smart contracts operate on the Ethereum blockchain through a system of code deployment and autonomous execution. These contracts are essentially pieces of code deployed on the blockchain that execute transactions based on predefined conditions. When interacting with a smart contract, users submit transactions that trigger the execution of terms defined within the contract's code. This follows a structured if, when, then logic, wherein specific actions are performed when certain conditions are met. Smart contracts are unchangeable and reside at specific addresses on the Ethereum blockchain, ensuring transparency and security throughout their lifecycle. For example, consider a scenario where a property transaction is facilitated through a smart contract. The buyer locks funds in the contract, which is programmed to release the payment only upon the completion of specific conditions, such as the transfer of ownership documents and verification of property status. This ensures that funds are released only when both parties fulfill their obligations, reducing the risk of fraud or disputes. Once activated, smart contracts are irreversible, meaning transactions cannot be undone once executed, adding an extra layer of security to the process. Writing smart contracts on the Ethereum blockchain requires proficiency in programming languages such as Solidity and Viper, which are specifically designed for smart contract development. Familiarity with languages like JavaScript and Python can also be beneficial. The code defines the rules and logic of the smart contract, dictating how it will execute transactions based on predefined conditions. Once the code is written, it needs to be deployed to the Ethereum network, which involves sending a transaction containing the smart contract code and paying transaction fees known as gas. Smart contracts on Ethereum find practical applications across various industries, particularly within the decentralized finance (DeFi) ecosystem. For instance, they enable the issuance of crypto-backed stablecoins, where users lock crypto assets in a smart contract to mint stablecoins. Additionally, decentralized lending protocols leverage smart contracts to facilitate peer-to-peer lending without the need for intermediaries, creating autonomous money markets for crypto holders. Furthermore, smart contracts power peer-to-peer trading on decentralized exchanges, DEXs, matching buyers and sellers without the involvement of centralized entities. Exploring Ethereum's decentralized applications, DApps, reveals numerous examples of smart contract use cases in action. These include token swaps, lending platforms, payment systems, investment platforms, and insurance services, all of which leverage smart contracts to automate processes and ensure trustless interactions. By interacting with these DApps, users engage with smart contracts seamlessly, often without even realizing it. This underscores the versatility and potential impact of smart contracts in revolutionizing traditional financial and contractual practices. 10 versatile functions of smart contracts. Improving efficiency in digital advertising campaigns. Smart contracts offer a potential solution to enhance digital advertising campaigns by establishing transparent and automated payment mechanisms. For instance, advertisers can use smart contracts to ensure that publishers meet specific targets before receiving payment, thereby reducing the risk of fraudulent activities such as pixel stuffing. By leveraging oracles to verify predefined conditions, smart contracts can trigger payments automatically, improving efficiency and accountability in advertising transactions. Furthermore, Smart contracts could facilitate trust and transparency between advertisers and publishers by eliminating the need for intermediaries and ensuring fair compensation for services rendered. Enhancing customer experience through smart contracts. In the world of customer experience, smart contracts can play a pivotal role in promoting stronger relationships between businesses and consumers. For example, businesses can incentivize customer engagement by offering discounts or rewards through smart contracts based on specific actions, such as creating playlists on streaming platforms. By automating the delivery of personalized offers and recommendations, smart contracts can enhance the overall customer experience and increase brand loyalty. Additionally, the transparency and immutability of smart contracts contribute to building trust and credibility among customers. Revolutionizing entertainment consumption with smart contracts. The integration of smart contracts into blockchain technology has the potential to revolutionize how consumers interact with digital entertainment content. Through the use of non-fungible tokens, NFTs, smart contracts enable transparent and secure ownership verification for digital assets such as artwork, music, and videos. Moreover, smart contracts facilitate peer-to-peer transactions, eliminating the need for intermediaries and reducing transaction costs. By automating royalty payments to content creators, smart contracts ensure fair compensation and incentivize the production of high-quality entertainment content. Streamlining financial transactions with DeFi smart contracts. Decentralized finance, DeFi, platforms leverage smart contracts to revolutionize traditional financial transactions, offering benefits such as increased efficiency, transparency, and accessibility. Smart contracts enable peer-to-peer lending, automated trading, and asset management without the need for intermediaries. By automating processes such as loan evaluations and insurance claims processing, DeFi smart contracts reduce operational costs and minimize the risk of fraud. Moreover, the transparency and immutability of blockchain technology enhance trust and confidence among participants in the financial ecosystem. Improving communication in healthcare with blockchain. In the healthcare industry, smart contracts powered by blockchain technology can streamline communication processes between insurers, healthcare providers, and patients. By storing patient data securely on a blockchain, smart contracts enable efficient information sharing, regulatory compliance, and claims processing. For example, smart contracts can automate insurance coverage verification and payment release processes, reducing administrative burdens and improving patient outcomes. Additionally, blockchain-based identity management solutions enhance data security and privacy, mitigating the risk of unauthorized access and identity theft. Automating HR workflows with smart contracts. Smart contracts offer promising solutions for automating human resources, our workflows, simplifying processes such as employment verification, reference checks, and payroll processing. By encoding employment contracts and policies into smart contracts, organizations can ensure compliance and enforceable agreements without the need for intermediaries. Moreover, smart contracts enable transparent and tamper-proof record-keeping, reducing the risk of disputes and enhancing trust between employers and employees. Additionally, blockchain-based identity management solutions enhance data security and privacy, mitigating the risk of unauthorized access and identity theft. Strengthening identity and access management with blockchain. In the scope of cybersecurity, smart contracts powered by blockchain technology can enhance identity and access management, IAM, systems by providing secure and tamper-proof authentication mechanisms. By leveraging blockchain's immutable ledger, smart contracts enable transparent and auditable identity verification processes, reducing the risk of data breaches and identity theft. Furthermore, smart contracts can automate access control policies, ensuring that only authorized users can access sensitive information and resources. Additionally, blockchain-based IAM solutions offer scalability and interoperability, enabling seamless integration with existing IT infrastructure, transforming relationships in the insurance industry. Smart contracts hold the potential to transform the insurance industry by automating claims processing, enhancing transparency, and encouraging trust between insurers and policyholders. Through blockchain technology, smart contracts enable real-time verification of policy terms and conditions, reducing the likelihood of disputes and fraudulent claims. Additionally, smart contracts can automate premium payments, policy renewals, and claims settlements, organizing administrative processes and reducing operational costs. Moreover, blockchain-based insurance solutions offer increased data security and privacy, protecting sensitive information from unauthorized access and tampering, enhancing supply chain management with blockchain. Smart contracts integrated into blockchain technology can revolutionize supply chain management by enhancing transparency, traceability, and efficiency throughout the supply chain ecosystem. By encoding contract terms and conditions into smart contracts, organizations can automate processes such as product tracking, inventory management, and payment settlements. Additionally, blockchain-based supply chain solutions enable real-time visibility into product movement, reducing the risk of counterfeit goods and supply chain disruptions. Moreover, smart contracts facilitate seamless collaboration between stakeholders, ensuring compliance with regulations and sustainability goals. Optimizing energy distribution with blockchain. Blockchain technology offers opportunities to optimize energy distribution by enabling transparent and efficient transactions between energy producers and consumers. Smart contracts can automate energy trading, billing, and metering processes, reducing administrative overhead and ensuring fair compensation for energy producers. Additionally, blockchain-based energy solutions enable peer-to-peer energy trading, allowing consumers to buy and sell excess energy directly to other users. By leveraging blockchain's immutable ledger, smart contracts enhance data integrity and trust in energy transactions, paving the way for a more decentralized and sustainable energy ecosystem. Embracing permissionless innovation. Smart contract deployment on Ethereum. The concept of permissionlessness lies at the core of blockchain technology, particularly in the context of smart contracts deployed on platforms like Ethereum. Unlike traditional systems where access and control are centralized, blockchain networks operate on a decentralized basis, allowing anyone with the necessary skills and resources to participate. In the case of smart contracts, individuals have the freedom to write and deploy their own contracts without requiring permission from any central authority. This open accessibility democratizes the development and deployment of smart contracts, advancing innovation and inclusivity within the blockchain ecosystem. To write and deploy a smart contract, one must first familiarize themselves with smart contract languages such as Solidity or Viper. These languages, specifically designed for blockchain development, provide developers with the tools and syntax needed to create executable code for smart contracts. Once the contract code is written, deploying it to the network involves initiating a transaction, similar to sending cryptocurrency from one address to another. However, unlike simple ETH transfers, deploying a smart contract incurs higher gas costs due to the computational resources required for contract execution. Ethereum's developer-friendly environment further facilitates the permissionless nature of smart contract deployment. By providing accessible languages like Solidity and Viper, Ethereum empowers developers of varying skill levels to contribute to its ecosystem. Moreover, the availability of resources such as documentation, tutorials, and community support enhances the accessibility of smart contract development on Ethereum. This permissionless approach not only democratizes access to blockchain technology but also encourages creativity and innovation as developers explore the potential applications of smart contracts in various industries and use cases. Smart contract challenges. Off-chain data and contract size restrictions. Smart contracts, while powerful in their ability to execute code autonomously on the blockchain, do have limitations that constrain their functionality. One significant limitation is their inability to directly access or interact with data from external, off-chain sources. This constraint arises from the fundamental design of blockchain systems, which prioritize security and decentralization by relying solely on on-chain data and consensus mechanisms. Consequently, Smart contracts are unable to respond to real-world events or access information beyond the blockchain network without compromising these principles. To address the need for off-chain data in blockchain applications, developers rely on oracles, which act as bridges between the blockchain and external data sources. Oracles serve as tools that fetch and verify off-chain data, making it available to smart contracts for execution. By leveraging oracles, blockchain applications can access real-time information, such as market prices, weather updates, or IoT sensor data, enabling them to make informed decisions and respond dynamically to changing conditions. Another limitation of smart contracts lies in their maximum size restriction, which can impact the complexity and functionality of contracts. Smart contracts on Ethereum, for example, are limited to a maximum size of 24 kilobytes. Exceeding this size limit can result in the contract running out of gas during execution, rendering it unusable. To mitigate this limitation, developers employ techniques like the diamond pattern, a design pattern that enables modular and scalable smart contract architectures. By breaking down large contracts into smaller, interconnected components, developers can circumvent the size restriction and build more robust and flexible applications on the blockchain. Emerging potential of smart contracts. Smart contracts are still in their early stages of development, but their potential to revolutionize various industries is vast. As blockchain technology continues to evolve, smart contracts will become more sophisticated and widely adopted, leading to greater efficiency, transparency, and security in global business collaborations. However, it's essential to recognize that challenges remain, such as regulatory hurdles and technical limitations, which must be addressed to unlock the full potential of smart contracts. Wealth generation in the metaverse. In the metaverse, smart contracts have the potential to generate wealth through decentralized finance, DeFi, protocols, non-fungible token, NFT, marketplaces, and virtual asset trading platforms. As virtual worlds become increasingly interconnected and integrated with the real economy, smart contracts will facilitate seamless transactions and interactions, enabling individuals and businesses to monetize digital assets and participate in new economic paradigms. Opportunities in the industrial metaverse. Similarly, in the industrial metaverse, smart contracts can drive wealth generation through optimized supply chain management, automated manufacturing processes, and enhanced data integrity. By leveraging blockchain technology and smart contracts, industrial ecosystems can achieve greater efficiency, traceability, and trust in global business collaborations. Smart contracts enable frictionless transactions and automate contractual agreements, reducing costs and increasing productivity across the supply chain. Collaborative innovation. Moreover, smart contracts enable collaborative innovation by advancing interoperability and standardization across diverse ecosystems. In the metaverse and industrial metaverse alike, smart contracts facilitate seamless collaboration between stakeholders, enabling them to share resources, exchange value, and co-create new solutions. This collaborative approach to innovation promotes creativity, accelerates development cycles, and drives sustainable growth in global business collaborations. Future outlook. Looking ahead, the future of smart contracts is promising, with potential applications spanning various industries and sectors. As blockchain technology matures and adoption rates increase, smart contracts will play an increasingly integral role in shaping the digital economy of the future. By embracing this transformative technology and leveraging its capabilities, businesses can unlock new opportunities for wealth generation and value creation in the metaverse and beyond. Conclusion. In summary, smart contracts represent a pattern shift in contract execution and automation, offering unprecedented opportunities for wealth generation and collaboration in the metaverse and industrial metaverse. While still in their early stages, smart contracts hold immense potential to revolutionize global business collaborations, drive innovation, and create value in diverse ecosystems. As stakeholders continue to explore and adopt smart contract technology, the future holds exciting possibilities for economic growth, efficiency, and prosperity in the digital age.